Hello everyone. First of all, I'm always open for any comments, questions, requests, suggestions, improvements, and feedback. Now, today I'm going to talk about this bar, this one, which you may have noticed some helicopters with two rotor blades have. It's called the stabilizer bar, and it's part of a kind of integrated system for stabilizing helicopters, though it's still used, but it's kind of being replaced by computer systems nowadays. Um, what this does, this bar spins along with the rotor, and it works like a Foucault pendule or like a gyroscope. It wants to keep spinning in the same plane and along the same axis. So if the helicopter does any movement, any tilting, this wants to maintain the same orientation. And this is used as a mechanical sensor basically to pick up on any tilt. And this is mechanically connected over the rotor head to the rotor blades and is essentially mixed in with the cyclic pitch to always steer against the current movement of the helicopter. So if the helicopter starts tilting left, for example, then this bar will want to keep rotating on the same plane, and that thus this bar will basically be tilted right against the rotor head, and that will mechanically then cause the rotor blades to tilt to a pitch cyclic rightwards, and that will then, together with precession of gyroscope, then basically make the helicopter roll right so that it counteracts the rolling left. This makes the helicopter slightly less maneuverable but more stable if it is mixed correctly in with the cyclic input. Of course, depending on how this mix works, it makes the helicopter less maneuverable and more stable to different degrees. Now, two-bladed rotors are especially unstable because basically if you look at the rotor at any moment, of course it's rotating quickly and over a longer time it can be approximated as a rotor disk, but if you look at the rotor at one moment, it's essentially one long object and it doesn't have like a plane, it's more like a line from one point to another. And so the helicopter can kind of break out for a fraction of a second along this axis, and thus the helicopters with two rotor blades are inherently a little bit more maneuverable and less stable than helicopters with more rotor blades. This is only a very small effect. Of course, helicopter flight dynamics and aerodynamics is really complicated already. Anyway, some helicopters with two rotor blades have this, some don't. Some have computer systems instead to stabilize the helicopter. Some just don't need it and just are a little more maneuverable and a little less stable, or they already were rather stable flight dynamically. For example, the Cobra, the AH-1 Cobra does not have this, but the UH-1D, which you can see here, does have this. Now, this system is only present in two-bladed helicopters for several reasons. For once, it's mostly needed for two-bladed helicopters, but mostly it's just mechanically much more difficult to build for more-bladed helicopters. It's hypothetically possible, but it would make very little sense and it would be very inefficient. Now, there are several ways to implement this mechanically. In the rotor head, of course, it has to be somehow mixed with the cyclic commands. There are several ways to do this. Usually, it's some kind of simple mechanism that basically takes an average or weighted average of both the cyclic input and this bar to actually go into the rotor blades. There is one very interesting different way that is mostly used for radio controlled small helicopters, where the stabilizer bar actually has tiny pedals that work like rotor blades on it. They don't actually contribute anything much to lift or steering of the helicopter, but the cyclic commands don't go directly into the rotor blades at all. The cyclic commands only go into this bar and into its pedals, and then the physics dictating the movement of this bar and the aerodynamics of the pedals do the mixing of those signals basically. And the bar is the only thing that actually moves the rotor blades together with collective pitch. There are a few reasons why this is a very popular solution in radio controlled helicopters, but it's not really seen in big manned helicopters. They have to do with mechanics and complexity. In a small radio controlled helicopter, the really complicated rotor head is already shrunken down to less than an inch often, so you don't want the mechanism to be more complex than it really has to be. And also, due to flight dynamics, much smaller helicopters do tend to have a somewhat higher rotor RPM. Now, this differs from model to model again, but without wanting to insult any radio controlled helicopter pilots that vastly differ from this, because sea helicopters have a really wide range of rotor RPMs, but on average, they're around 1000 RPM, so roughly 4 times that of a big helicopter. And that makes this kind of system where the cyclic commands only control the stabilizer bar and that then controls the rotor blades much more reactive, whereas in a big helicopter it would react way too slow. So in many, especially aerobatics focused radio controlled helicopters, you can see this kind of pedal stabilizer bar, while in many older two-bladed manned helicopters you can see the pedal-less, simply weighted bar that is then mechanically mixed with the cyclic pitch to control the rotor blades. I hope this was somewhat interesting, and thanks for watching.